Hello again. This time we're going to learn about OCAML strings, and let's start off where we stopped in the last video. Just a quick reminder of the list of modules in the OCAML system. If you remember, we googled the OCAML system and then we accessed this web page here, and then we can have a list of all the modules. If you go down to the bottom, it's index of modules. Save this page if you want, because this is a very good reference, especially the tutorials here. But anyway, by the way, speaking about modules, remember that the Pervasives module, where is it? P is here. These are alphabetically ordered. Pervasive, the OCAML, this one is initially opened, yes. So this is all by default available for us. And if you want to have a look at all the functions there for exception handling, we'll come to that. For comparisons, these are considered functions in OCAML, as you can see. For the compare function, min and max by default there. Not and logical or an and all that. These are all available by default. And hopefully now we are familiar with it and we can read it and understand what it does. So for example, max int returns the greatest representable integer. Min int is the minimum integer and things like that, with bitwise operations, logical and, logical or, the XOR and not and things like that, shift left and shift right. I'm sorry. And everything you can see here for the exponential function, floating point subtraction, floating point addition. Remember when we learned about these, the plus dot, minus dot, star dot and slash dot, and that's for exponentiation and all the rest of it. Anyway, we're not gonna spend too long here. I hope you can find your way until to this page and then read about that. Let's go to the string module and have a look. And as I said, we'll start where we stopped last time with that sub function. Where is it? So we're familiar with length. Should return the length of a string. Where is my command line? So let me clear the screen first, and then go on to the top level. We can open string, or we can use it the fully qualified name with string dot and then a function name. So let's have a look at, for example, let's just test length, for example. Length, and we pass the string, and it gives me 6, yeah, but it starts with 0, so 0, 1, 2, 3, 4, 5. That's the indices of these characters in the string. We've seen get to retrieve a certain character. We'll just give it the string and an index. Of course, this string here can be a variable, so we can say let s equals, for example, we are, or maybe checking the string module, and then we can pass it to any function we want. So for example, we'll just pass it s, and then that's 33 characters from 0 to 32. Now let me go to, so set modifies a string. The name says it all, so we can actually modify a certain character at a certain index and change it. But let's go to make and create. We can return like a fresh string of length n. The string initially contains arbitrary characters, so we have to modify it. Make returns a fresh strings of length n filled with character c. Yes, so here we create a string but with random characters of a length int or of length n, whereas here we make a string, so we create a string with length n and filled with the character c. We have to provide a character. But let me go to sub. Returns a fresh string of length len. Right, yeah. So of length len, we give the start index length len containing the substring of s that starts at position start and has length n. Len. I'm sorry. Yes. So we give it a starting index and a length. So if we look at this method here, I'm sorry, this string here. So 0, 1, character 0, character 1, 2, 3, 4, 5. So let's start at character 3 and give it length 3. It should return ARE, the R. Yes, so we can copy and paste that for our reference. And luckily the variable name is actually s, as you can see here. So we'll save that. So for example, we'll start at character 3 and then of length 3 it should return R. Yes, if we give it, for example, start at character 3 and then that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we say 12, we will return back our checking. As you can see, I hope this makes sense. I don't know why last time it didn't work properly. I think the string was actually, this is a test, wasn't it? So we say string.sub, and then let's say, for example, this is, oh yes, I know why what it was doing. It was returning is over the this space, and then this is here. So is space is here. Oh, okay, it's making sense now. So let's leave it, and then have a look and to use something else more. Maybe, for example, we can concatenate strings. And by the way, we can concatenate strings using the hat on OCAML. So this, and then hat space hat, and then is, and that should concatenate the strings. Yep. Or maybe you can use concat and pass it string and a string list. So concatenates the list of strings. Yes, we pass it a string list, inserting the separator. Yes, so we can have a list of strings. Yes, and then concatenate all the elements of that list to make sort of a sentence maybe, but we have to pass it a separation like space or comma or semicolon. Let's test that. So let's define or declare a list of strings, and that's how we do that. Let, for example, L equals, remember we briefly mentioned lists in OCAML and said this is how we do them with a square bracket. So let's say this, and then elements are separated by semicolon is, and then another semicolon a, another semicolon, and then another string. Yes, so that's my list of strings, and then what I can do is I can concatenate all these words to make a sentence, but I need to specify a separator. Where am I? Yes, so what I can do here is I can say, for example, separate my string by a space, and then pass it a string name and it return a string. So I can say, for example, let s equals that, and s will contain that value. Or maybe I can separate it maybe by, for example, anything like, for example, comma and then L, and it return a comma separated string. As you can see, instead of space we have these commas. Just want to demonstrate how it works. I'm sure it's making sense. And then we have these map functions, or to iterate through all the elements. These are very, very interesting functions, by the way, that iterate and map. So the iterate, what it does is it applies a function f in turn to all of the characters of s. Yes, what we do is we pass it a string and a function. Yes, a function, and it will apply a function and a string, and it will apply a function on all the elements of a string. And we can have an anonymous function here. So for example, let's this is, I'm sure you find this very interesting. You're gonna love this. So let me copy and paste that. Yes, so the function should be an anonymous function. For example, let's say fun anonymous function, as we learned before. So fun x, i.e. the element x, and what do we do with that x? We apply, for example, something. So we say print, because it applies to every character, so we need print char, for example, x, and then we pass it as a string. So maybe the string s here. Yes, so s is, this is a string, and what we do here is this anonymous function here. X now is the argument, and because, as you can see here, it actually applies the function to all characters. So the input is every character from this string one by one. So x here is a character, and what we do is we print out that character. This is an anonymous function. This is how powerful OCAML is. I hope this is making sense. Print it out, and we print this is a test, and that's it. Returns a unit because it doesn't do much. It just has a side effect, which is to print out the characters, every character of that string. But we can do anything with that character inside this anonymous function here. This is the iterate. The map, what it does is it applies the function, but it actually returns the result in a new string. Yes, it returns the result in a new string. So for example, what I can do here is, instead of using iterate, I can say, for example, string dot map, and then I provide a function, again an element function, of a fun x. So what I can do, for example, with fun x is, of course I need to close it and provide my string, but let me double check something here. Yes, what I can do here, return a copy of the argument with all lowercase letters. What I want to do is, for example, I want to convert um, convert all the strings one by one into uppercase. Let me go to module char rather than string quickly. I hope it's not taking too long. Where's char? Character C, so char, and let's try to find, yeah, lowercase and uppercase. Convert given character to equivalent uppercase. Yes. So let's copy that, and notice now we're using module char, as you will see. So what I'm going to do now is I'm going to convert every character. So say char dot uppercase, and my character now is C because it iterates through all characters and then provided S. And what it'll do is it'll convert every character into its uppercase and return it as a string. So there in iterate, function doesn't return anything, it just executes that, and that's it. Whereas here in map, and the name says it all, we map this string into a new string by applying the function here. And here I'm using another module, which is module char, and the function is uppercase, converts a given character to its uppercase, or yes, uppercase, capital case equivalent. Yes, and likewise you can read the rest of the functions, and you can use the same thing for all other modules. As you can see, there's more of them at the bottom here. You can't see them. I'm sorry, I didn't want to capitalize that, but yeah, to maximize it. Yes, anyway, there's loads and loads of functions. Uppercase and lowercase here, they actually convert rather complete strings rather than individual characters. By the way, we have uppercase in string and uppercase in char. How do we actually differentiate between the two? Let's try it actually. So let's open module string. Yes, let's open module string, and let's open module char. And now what we have is we have the two modules open at our disposal, and inside them we have functions with the same name. How do we differentiate between the uppercase, for example, coming from string module, and uppercase coming from char module? Well, let's try it. So now it's actually open for us, uppercase. So if we pass it a character, then OCAML will automatically know that we are calling the one from char module. Whereas if we pass it a string rather than character, a string is double quote in OCaml, a character is single quote, this expression has type string, but expression was expected. Oh, it's actually giving this more precedence, so we need to find a way of actually rewriting that. But let's give it, yes, it's complaining because it's giving that more priority. The one we opened last, and we need to find a way around it, maybe by renaming that function. So let's say, for example, let s to upper equals string dot uppercase, and now we can use s to upper, just a way around it, s for example, and it should return the uppercase or the capital case of a given string. I hope this is making sense. This is quite interesting to know that it's giving priority to the last one, but that's a way. That's one way around it, to actually sort of have an alias, not alias, an alias for that function, so we can know which is which. Thank you very much indeed for watching, and I'll see you next time.